Hello, this is the Mod 7 review. Number 1, what is an equation in slope-intercept form that represents a line that passes through the points -6, -6, and -2, 4? Well, we can find the slope first. Is y2 minus y1 over x2 minus x1. You can label your points if you need. x1, y1, x2, y2. So we've got 4 minus a -6 over -2 minus -6. So we're going to get 10 over 4, which actually reduces to 5 halves. So our slope m is 5 halves. Well, we're not done. It didn't just ask us to find slope. We need to find the equation, so we're going to go ahead and plug it in over here. I'm going to go ahead and use, let's see, I used this point right here. So I'm going to plug that in. -6 equals the slope, which is 5 halves, times another -6 plus b. I can put that over 1 if that helps some of you. So we've got, when we multiply here, I've got a -15. All right, and then of course to solve for b, we add 15 to both sides, and that leaves us with 9 equals b. So we have m, we have b, so we have our equation. Y equals 5 halves x, don't forget the x, plus 9. Please circle all of your answers. Number 2 is pretty easy. We have the line R shown on the graph, and we want to know what the equation of the line is. Same thing, we still need 2 pieces. We need to know what m is, and we need to know what b is. So from the graph, I can read b, that's down here. It hits the y-axis at -1. And the slope, I can use that point and this point here. That sounds good to me. I'm rising up 2 and running over 3. And it's a positive slope, so I know I have a positive there. So my equation is y equals 2/3 x minus 1. Again, circle all of your answers. Number 3, is each equation equivalent to y equals 1/3 x minus 5? This is not multiple choice. Please do not guess on each one. Let's do it. A, we have to see if this simplifies to y equals 1/3 x minus 5. So we're going to do this. We're going to distribute the 1/3. Okay, we have 1/3 x plus 2. And we want it in slope-intercept form, so I want to subtract a 1, subtract a 1. This is going to say y equals 1/3 x plus 1. No, it does not match, so the answer to A is no. All right, let's do B. All right, slide these down a little bit. So B, same idea, we're going to distribute here. So y plus 1 equals 1/3 x minus 4. Okay, same thing, I want to get it in slope-intercept form. So y is going to be 1/3 x minus 5. Guess what? That matches the first equation, so that's a yes. All right, let's do C over here. Be able to see that one. All right, so this one's in standard form, still have to change it to slope-intercept. So first we're going to get rid of the x term. Don't forget that negative sign. I'm going to do my x's first because that's how I always do it in my classes. All right, we've got a negative, make that look nicer. We've got a -2x plus 30. And you need to divide by your -6. So this says y equals Negative divided by a negative here is going to be a positive, and I can also simplify that to a positive 1/3 x, and that's minus 5. Positive divided by a negative is a negative, and so that one is a yes. And the last one, same thing, slope-intercept. Negative 3y equals negative x minus 5. I'm putting the x term first to make it look like slope-intercept form. Dividing by negative 3 to give me y equals, this is going to be, remember this is a 1 out front here. Okay, so that's a 1/3, positive 1/3 x. And this is going to be a positive 5/3, which is not the same as minus 5, so this would be a no. Notice how I show all my work. The solution to which inequality is graphed below? Well, let's actually figure out what the graph of this is. What is my m and what is my b? Well, b is here on the y-axis. That looks like a 3 to me. And the slope, we know it's going downhill, so I know it's a negative. Well, let's see. I'm going down. It looks like down 1/1 every time, right? Down 1/1, so that's negative 1. You can put it over a positive 1 if you'd like. So if you know that, you can write your equation in slope-intercept form. Instead of y equals, since it's an inequality, we'll use an inequality. We can look at the dotted line and know it's not going to have an equal bar underneath. And we also know that it's shaded above, so that's a greater than. And we have mx plus b, so that's negative x plus 3, or negative 1x, if you will. And then we can, of course, change that into standard form, like all the answers are. To change it to standard form, we just add x to both sides to get, I'll write x first, x plus y is greater than 3, which matches answer C. Is each ordered pair a solution of the inequality y is less than or equal to 2x minus 3? Well, we know this is an x and this is a y, so we're just going to plug that in using this inequality each time. So my first one is going to be y, so I need 2 is less than or equal to, we've got 2x, so that's 2 times 3 minus 3, just plugging it in. So let's see, you have to see if it is true here. We've got 6 minus 3. 2 less than or equal to 3. Is 2 less than or equal to 3? Yes, it is. This is true. So the answer to this is yes. So this is what I'm circling, yes, because that's my answer. If it's true, it's yes. All right, here we go. X and y, just plug it in. Same equation, same inequality. Y, which is 2, is less than or equal to 2x, so 2 times negative 3 minus 3. Let's see if this one's true. Is 2 less than or equal to negative 9? No. It's false, so the answer is no. Okay, we've got, not too far, all right, we got y, so if y is less than or equal to 2x, 2 times 0, minus 3. So negative 2 is less than or equal to, well, this part's just 0, so it's negative 3. Be careful. Is negative 2 less than or equal to negative 3? No, it's actually bigger. So this is false. So the answer to this one is also no. And the last one, 7 is less than or equal to 2 times x, so 2 times 5 minus 3. 7 less than or equal to 7? Well, since it has the equal sign underneath, it can be equal, so this is true. And the answer is yes. For going to write an equation in slope-intercept form of a line that passes through the point 12, -7 and has a slope of 1/4. So slope-intercept form looks like this. So far, we know an x and a y and an m. So we can plug those in to find b. So -7 equals the slope m times my x, which is 12. I'm going to put 12 over 1 to make it easier. Okay, I can solve for b here. Simplify this section first. This is just a 3. And subtract your 3 on both sides to solve for b. Alright, once you have b and you have m, you can just write your equation. Y equals 1/4 x, don't forget the x, minus 10. Number 7, Leah has a snack budget of $36. She can buy walnuts at $6.25 per pound and cashews at $9.20 per pound. We want to write an inequality, important information there, that represents the number of pounds of walnuts, W, and cashews, C, that she can buy. So how much can she spend altogether? Well, the most she can spend is $36. So that's going to be what we have to come out to equal or be less than. So we want this to be less than or equal to 36. Well, she's buying walnuts and cashews, and walnuts cost $6.25 times however many walnuts she buys, and the cashews are $9.20 times however many of those she buys. So the price, this is of course the price of the walnuts, plus the price of the cashews has to be less than or equal to 36. So that's our answer. Got another write an equation in slope-intercept form. I've got the intercept, and I can find the slope going down 2 over 4. It's -2 over 4, which reduces to -1/2. And it's just y equals mx plus b. Mx plus b. Number 9. Tanya is raising money to go on a field trip. She is selling rubber bands for $3 and stickers for $1. The cost of the field trip is $36. This time we're writing an equation to show how many stickers and bracelets that she must sell to raise money for the trip. This is very similar to problem 7 that we just did. So the total she needs is $36, so it's going to equal $36. Well, we have bracelets for $3 and we have stickers for $1. So we can say, why don't we call bracelets B? They didn't tell us what to call each one. Bracelets equals B, and we'll call stickers S. You can use X and Y if you want. Doesn't matter what you use for your variables unless they tell you. So I'll call bracelets B. So we've got $3 times the number of bracelets that she sells, and $1 times the number of stickers that she sells. In fact, let's actually change this to X and Y since our graph for the next one is X and Y. So you could have written this, 3x plus 1y equals 36. Excuse me. I do tell my kids that we usually use X for the first one that we see. That's why I used X for the bracelets. So unless they tell you specifically, I would go with the first one for X. And of course it makes sense here because my graph on the next one has X for bracelets. So we want to graph this for number 10. By the way, this is the answer for number 9. And then for number 10, we're going to use this to graph. The easiest way to graph this one is going to be to find our intercepts. So the x-intercept, the x-int, we're going to plug in 0 for y. So that's 3x plus 0 equals 36, which means 3x will equal 36. And when we divide by 3, we'll get x equaling 12. Okay, so then we'll have our y-intercept. This time we have to plug in 0 for x, so that's 3 times 0 plus y, 1y is y, equals 36, so y is going to just be 36. Easy. So if we have our two intercepts, let's go back up a little bit, we can graph them here. Y equals 36. We've got y equals 35 if that line's a little bit more than that line is 36. X is 12. Well, if I've got a line between 10 and 15, I'm going to say that's 12.5, so it's really close to that line. All right, and then you just connect those pieces. Number 10 also asked us, besides graphing the problem from number 9, I'm not sure why it's number 8, let's change that to number 9. If Tanya sells 8 bracelets, how many stickers does she need to sell to raise enough money for the field trip? Now, some people like to read a graph, but I like to do it algebraically. So if she sells 8 bracelets, well, bracelets is our x. So we're going to write this down. We've got 3x plus y equals 36. If we plug in 8 for our x, what do we get for y? We can solve for y here. We get 24. Okay, and subtract 24 from both sides, and we're going to get, that's 12. 12, that's stickers. We want to use units. 12 stickers. She'd have to sell 12 stickers in order to meet her goal if she sold 8 bracelets. Number 11. The function f of x represents the amount for Bubby's Bakery. I'm going to label this. Bubby's Bakery charges it, so it stands for what they charge in dollars for X fruit tarts. And G of X represents the Tasty Tarts and what they charge for X fruit tarts. So really this is just reading the graph, reading the table. Which bakery charges less for 48 tarts? Well, X is our fruit tarts, so find where X is 48 and figure out which one charges less. Well, obviously this is less than 120, so our answer is just Tasty Tarts. For how many tarts do the bakeries charge the same amount? And how much do they charge? Well, where would they be the same? Okay, well look, this is their charge. They both charge $90, so it would be, the first part of that question is for 36 tarts is when they charge the same, and how much do they charge? They charge 90 bucks. Easy one. All right, we've kind of already done this. Is -4, 3 a solution? So we're going to go ahead and plug them in for x and y. So we've got 3 is less than or equal to -2 times -4 minus 5. This is going to be a positive 8 minus 5. 3. All right, and is 3 less than or equal to 3? Yes, it is. This is a true statement. So if it's true, I can't even write the word true here, true, then we know it is a solution. So the answer is yes, And why is it a solution? Because it satisfies this equation. The point satisfies, I called it an equation, but it's an inequality. If the point satisfies your equation, or in this case, inequality, then it is a solution. We want to graph this inequality. To graph this, we're going to need two things. We need the m and b. Well, the b is going to be 2, and the m is -1/4. So we're going to go ahead and put a dot on the y-axis at 2. And the next dot is where we move down 1 into the right 4. Sorry for the messiness here. Down 1 into the right 4. That's our second dot. Okay, this piece right here says we're going to have a dotted line, not a solid line. So our dotted line, let's see if I can get that done here. Okay, we've got a dotted line here. It's going to continue out past each of these points, right? And where are we going to shade? Well, it says y is greater than, so we have to shade above the line. So it's all this here. Miguel has $1,360 in his checking account and $400 in his savings. He uses his checking account to pay his car loan, which is $100 per month. In how many months will his checking have the same amount as his savings? Well, I know an expression for his checking account. Looks like this. He's starting off with $1,360, and he's taking away money because he's paying his car loan, $160 per month. And in his savings, nothing happens. He just has money in there. His savings just has the $400. And it's saying when will those be the same? Keyword the same means equal. And we're going to solve for x. So I get -160 x equals -640. My negatives are going to end up canceling here. That's good. So when we divide by -160, we get x to equal 6. So the answer for this one is 6 months. All right. Number 15, if Miguel deposits an additional $320 into his savings account, in how many months will the balances be the same? Well, I did the same thing here. We're going to do the same thing, but instead of 400, we're just going to add another 320 to that. So 400 plus 320 is going to give me 720. So I'm going to do the same thing, but put in 720 on the other side. So 1360 minus 160x equals now 720 because he added money to his savings. And we'll do the same thing. We'll solve. Okay, so we get -160x equals